Hello, in this lecture we'll find out the area of the green triangle. In the drawing we have a quarter circle. We know that line segment PQ equals to 3 units, line segment AQ equals to 5 units in its length. In this angle APQ equals to 90 degrees. Our mission is to find out the area of the green right triangle AQO. So first of all, we will focus on the right triangle APQ, the right yellow triangle APQ, and we will implement on this right yellow triangle APQ the Pythagoras theorem. Here by PT is a relation from Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right yellow triangle is AQ, therefore the square of the hypotenuse is AQ square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PQ square plus AP square. Repeat again, in the right yellow triangle APQ, according to the Pythagoras theorem, AQ square equals to PQ square plus AP square. AQ equals to 5 units. According to what is given as the equation, therefore AQ square is 5 square, that is 25. And it is equal to PQ square. PQ is 3, therefore PQ square is 3 squared, that is 9. Plus AP square. AP is unknown, so we leave it as it is. We will find out that 25 equals to 9 plus AP square. Here we subtract 9 from this equation, and you get that 25 minus 9 is 16, and it is equal to AP square. Here we take a root out of this equation, and we get that AP equals to the square root of 16, that is actually 4. So we found out that the length of line segment AP equals to 4 units. So we write it down here that AP equals to 4 units in its length. We know that A or B is a quarter circle. We can easily complete the quarter circle to a circle, and then this point O will be the center of the circle. Again, this point O will be the center of the circle. Okay? So we have here rule number 2. We will implement rule number 2 in our drawing. According to rule number 2, the perpendicular from the center of the circle towards any chord bisects the chord. Okay, and repeat again rule number 2. A perpendicular from the center of a circle towards any chord bisects the chord. The center of the circle is at point O here. If from the center of the circle, that is to say from point O, we draw perpendicular on chord BC. Chord BC could be any chord. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as M. So the perpendicular OM on chord BC will bisect chord BC. That is to say, divide this into two halves. The first half is BM and the second half is MC. Therefore, BM of course equals to MC. So whenever you draw a perpendicular from the center of the circle towards any chord, it will bisect the chord. In this case, the perpendicular OM bisects chord BC, that is to say BM equals to MC. So we can actually implement rule number 2 in our drawing. Why? Because in our drawing, if we draw from the center of the circle, that is to say from point O perpendicular on chord AP, then this perpendicular from point O so actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AP is M, and according to rule number 2, the perpendicular OM bisects chord AP, that is to say, it divides into two halves. The first half is PM and the second half is MA. So PA equals to 4. So the first half will be 2, and the second half MA will be also 2. Okay? We define the intersection point between the perpendicular OM and line segment AQ as N. We define angle PAQ as theta. Therefore, in the small white triangle, white yellow triangle AMN, this angle equals to theta. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is actually the sum of the angles in any triangle. Likewise, if we focus on the white yellow big triangle APQ, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta, for the same reason that this angle equals to 90 degrees minus theta. So we will prove that the small right triangle AMN is similar to the big right triangle APQ. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle APQ in the big triangle, the big right triangle, is equal to angle AMN in the small right triangle. They are equal to 90 degrees. Repeat again. Angle APQ in the big triangle equals to angle AMN in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle theta, is a common angle that belongs to both triangles. So angle theta equals to itself. You can call to angle theta as angle PAQ, and it is equal to itself. We can call to angle theta also MAN. Repeat again. Angle PAQ is angle theta, and it is equal to itself. To angle MAN, that is also angle theta. We just called to angle theta two different names. It is equal to angle theta, that is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So, angle PQA in the big triangle equals to angle ANM in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again. Angle PQA in the big triangle is equal to angle ANM in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So I actually proved that all the three angles in the big triangle are correspondingly equal to all the three angles in the small triangle. Therefore, those two triangles are similar to each other according to angle similarity rule. So I write it down. The big triangle PQA is similar. This is the sign of similar to the small triangle AMN. According to angle similarity rule. What is angle similarity rule? Actually, if two triangles, all the angles in one triangle correspondingly equal to all the angles in another triangle, then the two triangles will be similar to each other according to angle similarity rule. And from the fact that the two triangles are similar to each other, we will conclude that PA in the big triangle, side PA in the big triangle over side MA in the small triangle is equal to side PQ in the big triangle over side MN in the small triangle, and it is also equals to side AQ in the big triangle over side AN in the small triangle. Repeat again. And conclude that PA over AM equals to PQ over MN equals to QA over AN. PA equals to 4 units, MA equals to 2 units, it is equal to PQ is 3 units, MN is unknown, so we leave it as it is, and it is equal to AQ equals to 5 units according to what is given us in the question. Over AN is unknown, so we leave it as it is. So in conclusion, we found out that 4 over 2 equals to 3 over MN equals to 5 over AN. From this equation, we conclude that 4 over 2 equals to 3 over MN. 4 over 2 equals to 3 over MN. 4 over 2 is 2, and it is equal to 3 over MN. Here we multiply this equation by MN, we'll get that 2 times mn equals to 3. Here we will divide this equation by 2, and we get that mn equals to 3 over 2. 3 over 2 is 1.5. In conclusion, we found out that mn equals to 1.5 units. So I write it down in the drawing that mn equals to 1.5 units in its length. So from this equation, we will conclude that 4 over 2 equals to 5 over an. Again, 4 over 2 equals to 5 over an. 4 over 2 equals to 5 over an. 4 over 2 is 2, and it is equal to 5 over an. We will multiply this equation by an, and we will get that 2 times an equals to 5. Here we will divide this equation by 2, and finally we will get that an equals to 5 over 2. 5 over 2 is 2.5 units, so 5 over 2 equals to 2.5. So I write it down in the drawing that an equals to 2.5 units in its length. Line segment an equals to 2.5 units. What is the length of line segment qn? The length of this line segment qn. From the drawing, it is very easy to see that qn equals to qa minus na. Again, qa minus na equals to qn. Very simple. So I write it down. That qn, this line segment, equals to qa minus an. Repeat again, line segment qn equals to qa minus an. So qn equals to qa. qa equals to 5 units according to what is given us in the question, minus an. You already found out that an equals to 2.5. So qn equals to 5 minus 2.5 is 2.5 units. So qn equals to 2.5 units in its length. So I write it down that the length of this line segment qn equals to 2.5 units. We know that any triangle can be blocked by a circle. I repeat again, any triangle can be blocked by a circle. Therefore, we'll block the right triangle AQO by a circle. So I'll copy the right triangle AQO in a new page, and we'll block it by a circle. Triangle AOQ. This is a right triangle. So actually, this is the right triangle AOQ that I copied from the original drawing. Now we'll block this right triangle by a circle. So inside this circle, we have peripheral angle AOQ that is equal to 90 degrees. I write it down. Peripheral angle AOQ equals to 90 degrees in its size. And we have here rule number 5 that states that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Okay, again on rule number 5, according to rule number 5, any peripheral angle that is equal to 90 degrees rests on the diameter of the circle. Here, peripheral angle ABC equals to 90 degrees, and therefore according to this rule, it must rest on the diameter of the circle. AC is the diameter of the circle, point O is the center of the circle, and therefore AC is the diameter of the circle. So you can see here that peripheral angle ABC equals to 90 degrees, and therefore it rests on AC, on chord AC, that is the diameter of the circle. We'll implement rule number 5 in our drawing. Because of the fact the peripheral angle A or Q equals to 90 degrees, you can conclude from it that it rests on the diameter of the circle. Peripheral angle A or Q rests on AQ, therefore AQ must be the diameter of the circle. According to rule number 5, AQ is the diameter of the circle. The diameter of any circle equals to 2 times the radius, so it is 2r from one side. But from the other side, AQ equals to 5 units, according to what is given as the equation. From this equation, we conclude that 5 equals to 2r. 5 equals to 2r, we'll divide this equation by 2, and you get that r equals to 5 over 2 is 2.5. R equals to 2.5. So the radius of this circle equals to 2.5 units. In the original drawing, we have here point N. This is point N. I copied from point N from the original drawing. But according to what we already found out, that AN equals to 2.5. And Q also equals to 2.5 units. And AQ is the diameter of the circle. We know that the radius of the circle equals to 2.5 units. Therefore, ON that is equal to 2.5 must be the radius of the circle, so it is equal to R. And A that is also equals to 2.5 must be also the radius of the circle. Okay? Because of the fact that QA is the diameter, and NO equals to 2.5, and the radius of the circle also equals to 2.5, therefore QN must be the radius of the circle, and from the same reason also NA that is also equals to 2.5, and the radius of the circle is also equals to 2.5, NA must be the radius of the circle. Okay, so we have here the two radii along the diameter of the circle. It is obvious that the touching point between the two radii must be the center of the circle, and the touching point is at point N. The touching point of the radius AN and the radius QN is at point N. Therefore, point N must be the center of the circle. N is the center of the circle. If you join points N and O by a straight line, what is the definition of line segment NO? Line segment NO starts from point N, that is the center of the circle, and ends at point O, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, NO is the radius of the circle, that is equal to 2.5 units. So I write it in the original drawing. and O is the radius of the circle, that is equal to 2.5 units. In the next step, we will implement the Pythagoras theorem on the right triangle OMA. So we copy the right triangle AMO in a new page and we implement on it the Pythagoras theorem. Side AM equals to 2 units. What is the length of side MO? MO equals to MN plus NO. Again, MO equals to MN plus NO. MN is 1.5, NO is 2.5. Therefore, in total, MO equals to 1.5 plus 2.5, that is 4. So in conclusion, found out that MO equals to 4 units. So this is the right triangle AMO as I call it from the original drawing. Here by PT, we get that OA square, the Pythagoras theorem, equals to MO square plus MA square. So OA squared, the square of the hypotenuse, equals to MO squared. MO is 4, therefore MO squared is 4 squared, that is 16, plus AM squared. AM is 2, therefore AM squared is 2 squared, that is 4. So 16 plus 4 is 20, so found out that OA squared equals to 20. Here we'll take out of this equation, and finally we'll get that OA equals to the square root of 20 units. OA equals to the square root of 20 units. In the next step, I will copy the right green triangle AOQ in a new page, and we will implement on it the Pythagoras theorem. AO equals to the square root of 20 units. This given us the equation that QA equals to 5 units. So this is the right triangle AOQ that I call it from the original drawing. According to the Pythagoras theorem, AQ squared equals to AO squared plus QO squared. AQ squared equals to AO squared. AO is square root of 20, therefore AO squared is square root of 20 squared, that is 20, plus AQ squared. AQ equals to 5, therefore AQ squared is 5 squared, that is 20 5. It is actually AO square is 20 plus QO square. It is not AQ square plus QO square. Here it is QO square. So AQ is 5, therefore AQ square is 5 squared, that is 25. So 25 equals to 20 plus QO square. 25 equals to 20 plus QO square. Here we subtract 20 from this equation. And we get that 25 times 20 is 5 equals to QO square. Here we take out of this equation and finally we found out that QO equals to the square root of 5. QO equals to the square root of 5 units. Write it down. QO equals to the square root of 5 units. Now it is very easy to find out the area of this green right triangle AQO. So the area of the green right triangle AQO here, the squared brackets is the sign for the area. The area of any triangle equals to the base of the triangle times the height to the base. The height must create 90 degrees with the base. Over 2. The base of the right triangle QO is QO, and the height is AO. Well, because AO creates 90 degrees with the base QO. So it is AO over 2. Repeat again, the area of the green right triangle AQO equals to QO times AO over 2. QO equals to the square root of 5 units. AO equals to the square root of 20 units, all divided by 2. So the area of the green triangle AQO equals to the square root of 5 units times square root of 20 units over 2. We have the algebraic identity that the square root of A times square root of B equals to the square root of AB. According to this trigonometric identity, we'll get that the square root of 5 times square root of 20 equals to the square root of 5 times 20, all divided by 2. 5 times 20 is 100, so inside the root we have 100 over 2. The square root of 100 is 10, over 2 is 5. So actually we found out that the area of the green right triangle AQO equals to 5 square units. 5 square units. Repeat again. The area of this right triangle AQO equals to 5 square units. In the next step, I'll summarize the lecture. So in this lecture we found out the area of this green right triangle AQO. It is given us the question that line segment PQ equals to 3 units in its length, line segment AQ equals to 5 units in its length, and this angle APQ equals to 90 degrees. Our mission is to find out the area of this green right triangle AQO. So first of all we focused on the right yellow triangle APQ, and we implement on this right yellow triangle the Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right yellow triangle is AQ, therefore the square of the hypotenuse A is AQ squared, and it must be equal to PQ squared plus PA square. I repeat again, in the right hand triangle, according to the Pythagoras theorem, AQ square equals to PQ square plus AP square. AQ is 5, therefore AQ square is 5 square, that is 25. PQ is 3, therefore PQ square is 3 square, that is 9, plus AP square. So 25 equals to 9 plus AP square. We subtracted 9 from this equation and found out that 25 plus 9 is 16, so 16 equals to AP square. We took out of this equation and we found out that AP equals to the square root of 16, that is 4. So here AP equals to 4 units. Then we presented to you a new rule and we implemented the new rule in our drawing. Actually, OAB is a quarter circle. It is very easy to complete the quarter circle to a circle, and then point O will be the center of the circle. And we have rule number 2, so that if we draw from the center of the circle perpendicular towards any chord, it will bisect the chord. I repeat on the rule. A perpendicular from the center of a circle towards any chord, bisect the chord. Point O is the center of the circle, so if from point O, that is the center of the circle, we draw perpendicular on chord BC could be any chord. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC is M. So the perpendicular OM bisects chord BC. That is to say, divide this into two halves. The first half is BM and the second half is MC. And of course BM equals to MC. So whenever you draw from the center of the circle a perpendicular towards any chord, it will bisect the chord. Implemented rule number 2 in our drawing. Here from the center of the circle, that is to say, from point O, we draw perpendicular on chord AP. So this angle equals to 90 degrees and this angle equals to 90 degrees according to construction. We define the touching point of the perpendicular from point O and AP is M. So the perpendicular OM must bisect chord AP, according to rule number 2. That is to say, it divides it into two halves. And because of the fact that AP in total equals to 4 units, the first half will be 2 and the second half, the first half PM will be 2 and the second half MA will be also 2. Okay, then we define the intersection point between perpendicular OM and chord AQ as M. Then we defined angle PAQ as theta. So if you focus on the right angle AMN, this angle equals to theta. This angle equals to 90 degrees. This angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees. And 90 degrees plus 90 degrees, it is 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right angle APQ, the right big triangle APQ, this angle equals to theta. This angle equals to 90 degrees, therefore this angle must be equal to 90 degrees minus theta. Then we proved that the right small triangle AMN is similar to the right big triangle APQ. Why? Those two triangles are similar to each other. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. Angle APQ in the big triangle is equal to angle AMN in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, we have angle theta is a common angle that belongs to both triangles, triangle AMN and the triangle APQ. Therefore, angle theta equals to itself. We called angle theta into two different names. Angle theta equals to PAQ, and it is equal to angle theta itself. Here, angle theta equals to MAN. Angle theta is called as angle MAN, and is equal to theta. So angle theta equals to itself, that is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again. Angle PQA in the big triangle is equal to angle ANM in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all three angles in the big triangle are correspondingly equal to all three angles in the small triangle. Therefore, the two right triangles are similar to each other according to angle similarity rule. The big triangle PQA is similar to the small triangle ANM according to angle similarity rule. What is angle similarity rule? Angle similarity rule means that if three angles in one triangle are correspondingly equal to three angles in another triangle, then the two triangles are similar to each other according to angle similarity rule. From the fact that the two triangles are similar to each other, we conclude that AP in the big triangle over AM in the small triangle equals to PQ in the big triangle over MN in the small triangle, and it is also equals to AQ in the big triangle over AN in the small triangle. I'll repeat again. We conclude that PA over AN equals to PQ over MN equals to AQ over AN. PA equals to 4 units over AM equals to 2 units equals to PQ, that is 3 units, over MN, that is unknown, and it is equal to AQ, that is 5 units, over AN, that is unknown. Repeat again. 4 over 2 equals to 3 over MN equals to 5 over AN. From this equation, we conclude that 4 over 2 equals to 3 over MN. 4 over 2 equals to 3 over MN. 4 over 2 is 2, so 2 equals to 3 over MN. Here we multiply this equation by MN, and we will get that 2 times MN equals to 3. 2 times MN equals to 3. Here we will divide this equation by 2, and finally we will get that MN equals to 3 over 2. 3 over 2 is 1.5. Here, 9/7 MN equals to 1.5 units. So from this equation, we will conclude that 4 over 2 equals to 5 over AN. 4 over 2 equals to 5 over AN. 4 over 2 is 2, so 2 equals to 5 over AN. Here we multiply this equation by AN, and found out that 2 times AN equals to 5. We divided this equation by 2, and finally we found out that AN equals to 5 over 2. 5 over 2 is 2.5. So in conclusion, we found out that AN equals to 2.5. Here, line segment AN equals to 2.5 units in its length. Okay, in the next step, we found out the length of line segment NQ. The length of this line segment NQ. What is the length of NQ? It is very easy to see from the domain that NQ equals to QA minus NA. Again, QN equals to QA minus NA. Repeat again. QN equals to QA minus NA. QA is 5, AN is 2.5. Therefore, QN equals to 5 minus 2.5, that is 2.5. So I found out that the length of line segment QN is 2.5. We know that any triangle can be blocked by a circle. Again, any triangle can be blocked by a circle. Therefore, we blocked the right green triangle AOQ by a circle. this is the right triangle AOQ that I copied from the original drawing, so, and we blocked it by a circle. So inside this circle, we have peripheral angle AOQ that is equal to 90 degrees. And we have rule number 5 that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. I'll repeat again according to rule number 5. A peripheral angle any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. ABC, angle ABC is a peripheral angle that is equal to 90 degrees. According to this rule number 5, it must rest on AC, that is the diameter of the circle. Here AC is the diameter of the circle. Therefore, peripheral angle ABC that is equal to 90 degrees must rest on AC, that is the diameter of the circle. So we can implement rule number 5 on our drawing. In our drawing, we have peripheral angle AOQ that is equal to 90 degrees. Therefore, according to rule number 5, peripheral angle AOQ must rest on the diameter of the circle. Peripheral angle AOQ rests on QA, therefore QA must be the diameter of the circle. Okay, so QA is the diameter of the circle. The diameter of any circle is 2 times the radius, so it is equal to 2r. From one side, from the other side, QA equals to 5 units according to what is given us in the question. From this equation, we derive that 5 equals to 2r. 5 equals to 2r. We divided this equation by 2 and we found out that r equals to 5 over 2. 5 over 2 is 2.5. We actually found out that the radius of this circle r equals to 2.5 units. Here I copied point N from the original drawing. This is AQ and I copied point N from the original drawing. So here AN equals to 2.5 and AQ also equals to 2.5. So here AN equals to 2.5 units and AQ also equals to 2.5. But 2.5 is the radius of the circle also. Here, 2.5 is the radius of the circle. Therefore, AN that is equal to 2.5 must be the radius of the circle. And Q that is also equal to 2.5 must be the radius of the circle. Why? Because both radii are located on the diameter of the circle. So both of them must be the radii of this circle. And those two radii met at point M. They touch each other at point N. Yeah. This is the touching point of the two radii. Therefore, it is obvious that point N must be the center of the circle. Point N is the center of the circle. Again, point N is the center of the circle. We join points N and O together by a straight line. What is the definition of line segment NO? Line segment NO starts from point N, that is the center of the circle. It ends at point O, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, NO is the radius of this circle that is equal to 2.5. Okay, here NO equals to 2.5 units. This is the radius of the circle. In the next step, we implemented the law, the Pythagoras theorem, on the right triangle AMO. So we copied the right triangle AMO in a new page and implemented on it the Pythagoras theorem. Line segment AM or side AM equals to 2 units. Line segment or side MO equals to MN plus NO. Again, MO equals to MN plus NO. MN equals to 1.5, NO equals to 2.5. Therefore, in total, MO equals to 1.5 plus 2.5 is 4. In conclusion, we found out that MO equals to 4 units. So here MO equals to 4 units, side AM equals to 2 units, this angle AMO equals to 90 degrees. So this is, I copied this triangle from the original drawing, the right triangle AMO. According to the Pythagoras theorem, in this right triangle, AO square or OA square equals to MO square plus AM square. Again, OA square equals to MO square plus MA square. OA square equals to MO square. MO is 4, therefore MO square is 4 square, that is 16, plus MA square. MA is 2, therefore MA square is 2 square, that is 4. 16 plus 4 equals to 20. In conclusion, we found out that OA square equals to 20. We took out of this equation, and finally we found out that OA equals to the square root of 20 units. Here, OA equals to the square root of 20 units. In the next step, I copied the right green triangle AOQ from the original drawing and we implement on it the Pythagoras theorem. This is the right triangle AOQ that I copied from the original drawing. AO equals to the square root of 20 units and AQ equals to 5 units according to what is given us in the question. AQ equals to 5 and AO equals to the square root of 20 units. According to the Pythagoras theorem, in this right green triangle, this is the green triangle, AQ square equals to AO square plus QO square. So AQ square equals to AO square. AO is square root of 20, therefore AO square is square root of 20 square, that is 20, plus QO square. AQ square. AQ is 5, therefore AQ square is 5 square, that is 25, and it is equal to 20 plus QO square. Here we subtracted 20 from this equation and found out that 25 minus 20 is 5, so 5 equals to OQ square. Here we took out of this equation and found out that QO equals to the square root of 5 units. Here QO equals to the square root of 5 units. Now it is very easy to find out the area of this green right triangle AOQ. So the squared brackets is the sign for the area. So the area of the green triangle AOQ equals to the base of the triangle times the height of the base over 2, that is the area of any triangle. The base is QO, the height of the base is AO, but because it creates 90 degrees with the base. Again, the base is QO and the height is AO. The base is QO and the height is AO over 2. QO equals to the square root of 5 units. AO equals to the square root of 20 units. All divided by 2. We have the algebraic identity that the square root of A times square root of B equals to the square root of A times B. According to this algebraic identity, we get that the square root of 5 times square root of 20 equals to the square root of 5 times 20 over 2. 5 times 20 is 100, so inside the brackets we have 100 divided by 2. The square root of 100 is 10. 10 over 2 is 5. So actually we found out that the area of the green right triangle AOQ equals to 5 square units. I repeat again, the area of this green right triangle AOQ equals to 5 square units. Okay, thank you very much.